My talk today is about how one can measure and mitigate the security risks in open source software. We will dive deeper into the work we have done at Google in collaboration with OpenSSF to make it easy for both open source developers and consumers alike. For folks that don't know me, I'm Abhishek. I'm a principal engineer and manager of the Google Open Source Security Team, aka Ghost in short. I've also been a core contributor to the Open Source Security Foundation since its early days of incubation. Prior to this role, I was also one of the founding members of Chrome Security and built all the vulnerability management practices from scratch. This includes projects like Cluster Fuzz and OSS Fuzz, which are highly prevalent in the open source community and found more than 30,000 bugs. Open source attacks are on a constant rise. For example, supply chain attacks grew 650% last year, which is a pretty staggering number. Every month, there was a significant attack which impacted more than 1,000 customers. A really prominent one was the Log4j vulnerabilities last December. It impacted every single software organization on the planet, and everybody scrambled to continuously patch as new vulnerabilities came coming in. We need to understand these security risks and be better prepared to handle them. We need to understand that open source software is not free. It looks so, but comes at a massive security cost. Many of the open source software is developed by volunteers in their free time, where security often comes last in their priority list. They don't have the resources to invest in a secure development lifecycle or have cycles to maintain it, for example, fixing security vulnerabilities. As our Google fellow Eric Brewer, an open source visionary, says, many eyes make all bugs shallow. But that is only true if those eyes are looking into the right place. In the case of open source, code is all open, but we don't have enough eyes paying attention to its security. One of the fundamental security aspects that is currently broken in the open source ecosystem is that open source consumers today, either big or small enterprises or government organizations, don't realize the security consequences before consuming a particular piece of open source software and adding it as a dependency. These dependency trees become more and more complex as you keep adding more third-party components to your code base. There are other things you don't realize, that whenever you add a new dependency, you might be bringing in several hundred or potentially even thousands of indirect dependencies. For example, the Kubernetes project has several thousand dependencies. The beauty of the open source ecosystem is that there is a solution for everything. The problem is you don't have one solution, but several dozen of them. So let's say you need a new JSON parser for your code base. There are several of them to choose from. Now, if your application is running a critical service or infrastructure, then picking the right choice becomes very important, as it will impact the security of your entire system. So what are we proposing? We are proposing that you need to set up an entry gate security risk assessment as part of your open source software ingestion pipeline. It's extremely important to have this process in place, as you can understand the high risk when consuming certain piece of software and try avoiding it. As an example here, one of these JSON libraries example YYJSON, is hosted under a user account, and most of the commits are done by that one developer without reviews. Do you think it's safe to use this in a critical subsystem? Probably not. What guarantees that the developer cannot commit malicious code without review, or his tokens, access tokens could be leaked, or even he could hand over this library to a malicious actor that comes with a bag of money? We need to understand all the risks that come in when consuming open source software. Open source ecosystem is complex, and the same applies to the risks it brings in as well. A traditional or myopic view of these risks is that we just need to find all the security vulnerabilities in our code base, and if we tackle those, we reduce our risk significantly. That is not true for the open source ecosystem. We need to understand the full comprehensive security posture of an open source project, and that involves understanding all these risks cited here. I have done a broad classification here to make you easily understand this. Beyond code vulnerabilities, you need to understand the important risks as well. For example, attacks like SolarWinds, CodeCurve, have taught us that supply chain risks are a very big deal, as attackers have found it much easier and much more reliable to attack our build pipelines rather than finding vulnerabilities in our code. Another important one is continuous security testing in your code base. So for example, you might not have vulnerabilities today, but what about tomorrow as the developers continuously keep modifying your code? For example, we have found numerous critical bugs in OpenSSL library via OSS First Service. Those were all caught on tip of tree or main branch and never made it into a production release, thanks to the continuous testing. And last but not the least, one of the really big risks with open source is that, is the project really maintained? Do these developers know how to respond to security incidents and fix security vulnerabilities, etc.? As we think of these supply chain risks, it's critical to mention this framework called Salsa. We at Google have been working on this internally for over a decade and have now open sourced it as part of the OpenSSF Foundation. Several of the industry contributors, such as VMware, Citibank, Datadog, are regular contributors to it and helping us to standardize it and make it an industry benchmark for evaluating supply chain risk. Right now, Salsa is focused towards supply chain build integrity aspect. For example, the highest level, Salsa 4, requires that all code changes be 2% reviewed and be in a hermetic, fully reproducible build process. We are thinking towards expanding this framework to include other risks that we mentioned in the previous slide. For example, code vulnerabilities, etc. We have discussed a lot of security risks in the open source ecosystem so far. So how do we measure them? We have realized that in order for this process to scale, we need to automate it. As part of OpenSSF, we released a project called Security Scorecards in late 2020. This project has two key goals. First is to completely automate the analysis and trust aspect when evaluating the security posture of open source projects. And the second goal is to provide a recommendation on how one can improve the security posture of those projects. It is also our goal to fundamentally improve the security of all critical open source projects that the world relies upon. Okay, so let's see how Scorecards evaluates these different kinds of risks. For code vulnerabilities, it hooks into the Open Source Vulnerability Service, or OSV. It is a free and very comprehensive open source vulnerability database. It is also the official vulnerability database for several languages, for example, Golang, Python, Rust, and KernelDB. Scorecard checks that if your package has any open vulnerabilities, and gives a score based on that. In the future, we plan to add more checks. For example, we want to standardize how security audits are done and how those results can be made public to all the consumers. An organization, OSTIF, is helping us here and will probably become a Scorecards check over time. Next is the maintenance checks. So vulnerabilities are bound to happen, but the more important aspect is your SDLC equipped to uptake patches in the fastest way possible? For example, we highly recommend hooking tools like Dependabot or RenovateBot that help with automated dependency updates. It is also critical to have a comprehensive testing in your CI/CD system, as you don't want their automated update to break your code. Another important aspect is this project equipped to accept and process new vulnerabilities? Has it really made it easy for reporters to report new vulnerabilities securely by declaring a security policy in codebase? And is the project active enough to fix them? The next category we have is continuous testing. I love these as they make sure that your code base does not regress as your developers write new code. For example, fuzzing is an important runtime testing technique to find vulnerabilities at scale. It is also part of the NIST standard for minimum testing requirements of our software project. And we have an OSS first service that is running on a massive 100,000 core compute cluster that is finding vulnerabilities in more than 500 critical projects continuously. So the Scorecards recommends integrating with this service. For static analysis side of the things are a little hard and false positive rates can be high. However, GitHub's CodeQL is a very promising offering, and they are standardizing queries with low false positives, and therefore we definitely recommend enabling it in your CI/CD workflows. Other checks include checking that you have some sort of testing in your code base to make sure it's stable enough. And last but not the least is supply chain risks. Supply chain risks have gained popularity, especially in the last 2 years after attacks like CodeCurve, SolarWinds happened. We can divide these risks into 3 broad types. Ones that happen at the source level, or the build step level, or when packaging happens. These are critical risks, as compromises at these levels are far easier, persistent, and very reliable in comparison to code vulnerabilities. A very fundamental thing that is broken in many open source projects is the lack of code reviews. If you are adding such dependencies, you are in a very high risk of compromise. For For example, the developer account could be hijacked due to lack of 2FA or leak access tokens, or they can get malicious themselves. Scorecards checks for that and has caught several problems here. For example, we are now advising Log4j developers on this aspect. They were doing code reviews, post commits through email notifications, and that is very hacky and could be compromised via things like Git history rewrites. Other things we check is the diversity of contributors. Some contributors from several organizations is better than a software project that relies on just one single developer. The second aspect of the supply chain risk is at the build level. A perfect example here is SolarWinds attack. We want to make sure that malicious artifacts are not injected during the build process. Scorecards tries to ensure this by looking at several aspects here. For example, it will check that everything is built from source and there are no checked-in binary artifacts in your code base. It also tries to make sure that the dependencies you pull is spent. This is very critical. Attacks like CodeCurve have shown that latest artifact that you consume, and if you cannot verify the hash of it, it could be completely compromised. So it is very important to pin to a stable version with a verifiable hash. Also, it is important that your GitHub workflow, which uses these access tokens, follow the principle of least privilege and explicitly declare it. That way, token compromises in your CI/CD system can't be used to commit code. The last kind of supply chain risks are at the packaging level. How do you ensure that the package you pull from, let's say, PyPy is not compromised? How can you ensure that the developer account is not compromised and you are not pulling in a malicious artifact that has been injected by an attacker in the package manager ecosystem? For it, it's important to cryptographically sign releases and a way to verify those. We have some basic checks in Scorecard right now to check for signature files in GitHub releases, but we are currently working on making this really proper with 6-store verification. This should come in the coming months, and we are also working with package managers to standardize this release process. Here is a list of all the security tools and frameworks we discussed so far. Feel free to check them out and make sure to include them in your secure development lifecycle and as part of your security risk evaluation. That brings us to the end. Here is a quick summary of what we discussed so far. Open source security risks are real, costly, and it is clearly evident from the exponential growth in attacks in the last few years, especially when you look back at 2021 and 2020. Attacks like Log4j, CodeCurve, Travis, etc., SolarWinds have all caused incident responses all over the planet. Second, you need to add security risk assessment as part of your open source software ingestion pipeline. Start integrating the Scorecard CI/CD checks as part of your continuous software development lifecycle. Third, you need to understand the full security posture of a third-party dependency. It should just include not just code vulnerabilities, but account for the other risks like supply chain build risk, continuous testing, and maintenance aspects as well. And lastly, keep your dependency trees minimal and in control. Understand those risks with indirect dependencies that come as part of it as well. That is about it. Thank you, everyone.